This Chinese already has the mic. Yeah. So now it's English menu.
投入して全部閉めて一旦止まりますと、スタート開始 OK ですよ、ということで、このグリーンの緑のランプがで今から開始します。
So once the green lamp is on, that means it's ready for process.
Start
Yeah.
process.
スタートボタンを押します。
Yeah. Press it. Start.
スタート
Yeah. And the process starts.
スタートボタンまず押しますと、隣の部屋でボイラーで蒸気を作る。でその蒸気をこの圧力容器、丸い容器全体の中に蒸気を送り込む。一気に送るんじゃなくて徐々にゆっくり蒸気を送っていく。
So the room that's on is the boiler, which creates the steam necessary for the process. So what happens is that once you press start, the boiler will generate the steam. Which will then be sent into the system. Actual technology was actually used by Ajinomoto to take out amino acids. And then it was then used but at a much lower temperature and pressure. So in order to process it,
Not so hot.
and then the menu already set for the 16 kind of ways to process. You just choose from the menu. Yeah. You want to treat what kind of waste? So macro EHP is the technology name. And before I explain the technology itself, let me briefly explain. After, can you send the slide? Yeah, sure. Sure. So our company was first founded in 1979 by our CEO, where he started working in Mitsubishi Electric.
Wow.
Yeah. Then he expanded the business itself by doing quality control business in the power plant sector in Mitsubishi Electric.
What is stand for JMW?
Japan and the world.
Japan and the world. History of Japan and the world.
First time I heard that. Yeah, so that's a very big, how should I say, vision of our CEO, that he wants to be the bridge between Japan and the world by not only exporting technology but importing good things from the world and brought into Japan. Yeah. So in 2006, they reorganized the company to what it is called right now, and so our company has been working with Mitsubishi Electric for approximately 40 over years now. And during that time, we are able to make such control panels ourselves and actually ship it out to Mitsubishi Electric. And we started our own what we call ozone generator, as well as we started working in the nuclear power plant construction in Japan. So in 2012, we started our renewable energy business, as well as our trade with our counterparts in China. And then in 2015, our company moved our headquarters to the city of Kobe, which is about 700 kilometers from where we are today.
They came all the way from Kobe
Yeah, by
just
car.
to do the demo for us.
Oh, okay. Thank you.
No,
Thank you.
no.
Thank you very much.
Thanks to their boss.
So in 2016, we had some colleagues,
Afrika kata gulila, Afrika.
yeah, started in Africa, and because of that, we opened our processing demonstration plant.
So this
Where in Africa?
No, this is here, but
Wow.
because of our context in Africa wanted us to wanted to look for technology that can process different kinds of waste without any separation or minimal separation. And so we looked across Japan and then we found this technology. We partnered with it, and then now in 2018 we've opened this demonstration plant. So the process itself is very simple. There's the machine that you saw just now, the control panel, the boiler, and then a condenser. So to start the process, you start the boiler by generating the steam. And as we are generating the steam, as we saw just now, we open the valve and then we put the materials. And once we've closed it, it's completely sealed. And then we start the process, which is fully automated. And inside, there's an agitator, so it slowly mixes the waste. So once we press the control panel as we did just now, then the steam from the boiler would go into the chamber itself. Now, because it's completely sealed and you apply pressure on it, naturally the temperature rises. And it would rise until approximately 220 degrees. And the processing time, depending on the type of waste, but it's approximately 30 to 60 minutes for one process.
one batch.
Yeah. So once the process is done, because it's highly pressurized, now we need to slowly discharge the pressure from it, which the steam will go through a condenser, which then we will turn back to liquid.
And the water, you can use underground water. Don't need pipe water.
Yeah.
Just a little water bit to create the steam.
So once inside is completely the pressure is down and safe to open, then we open the discharge valve, and then it would come out sort of like mud or soil like. So whatever you saw just now would be completely processed, and you see later
Gone.
on. Yeah.
Gone in 30 minutes.
So the
Last
entire
time people tell me, if you propose to who is our ex-PM, I did, because he killed the Mongolian, right? 30 minutes gone. Tak ada bukti yo.
So this is sort of technical, but what we are doing is that there's an area called subcritical water, which I'll explain later on. And then under the subcritical water, our process is here, which is about 220 to 225 degrees at maximum. So actually, what is subcritical water? But it's fairly simple. First, we all know that water boils at 100 degrees, right? Which is common knowledge. But if you But what happens is that once it's completely sealed, water does not boil at 100 degrees because it's completely, water molecules are held down by the pressure. However, when it comes to after a certain part, the water molecules can no longer be together, and what it does is it breaks. Now these broken water molecules are what we call subcritical water. So these water molecules that are broken are moving very quickly within the chamber, and that's what is able to process the waste. So in simple terms, it's a very big pressure cooker for waste. And so the features of this technology is that it's able to treat various organic waste. And as you can see, when during the process itself, it's completely sealed, so it does not harm the environment, no water contamination or soil contamination. And in the case of Japan, its operation cost is lower compared to an incinerator. Now, depending on different kinds of waste, the reusing of the waste differs. For example, like what we saw just now, a mixture of all different kinds of waste, domestic waste. What we normally recommend is that because it contains plastic, the same for medical waste as well. But if we're talking about livestock waste itself, without any mixture of plastic, there's a possibility of making it into fertilizers as well. Now, how does this all work? Is that, for example, if we take waste from medical facilities such as diapers, you recycle it by processing it here, and once it comes out, then you make it into pellets or organic pellets, and then you can use that for fuel for the biomass to generate electricity, which is the 3D model here that we have as well. And there's many different ways of doing of implementing this technology. One is that it is government owned, then it's able to treat various waste as well as reduce the waste that goes to the landfill. And at the same time, it is able to increase profit by not only the treatment of waste but also the sales of byproducts as well. The second scenario is if the waste collection company actually owns this technology. So like I mentioned previously, it reduces the landfill disposal fee, and so therefore it naturally reduces the transportation fees as well, and they're able to increase their profits from processing fees as well. Now this is a bit unique in the sense that mainly it applies to Japan. Farmer union owns this technology. What it does is that they can reduce on their waste by penny, so they are able to reduce that and that disposal fee. They are able to increase their breeding or planting area because, as you can see, on top of here there's about 300 dairy cows, and for their waste they need about this thing goes all the way about 100 liters. So they don't need that, they can just process this, make organic fertilizer and sell it. So the need for area would reduce as well. Now finally, if it's a medical waste processing company, then naturally they can reduce their energy consumption and able to generate their electricity themselves as well as sterilize the waste. So this is an environmental comparison, is that for incinerators, as you know, the smoke, the CO2, the dioxin, and the reuse of product can't be done. However, in the sense of our technology, is that as you can see, there's no discharge of smoke, exhaust. The only CO2 it uses by the boiler. Or if you want to make fuel out of it, the drying process later on. And the product usage, you can reuse it as fertilizer or fuel. And because it does not burn, so there's naturally no...
Can you go to the previous slides? Okay, you said medical waste, huh?
Yeah.
What type of waste?
Here we're looking at, for example, like diapers from the hospitals as well as
Human parts.
Human parts, yeah.
How about this syringe, all that?
The thing is that if some parts of it would come out the way it is, but it's completely sterilized. Yeah. So from a financial comparison, this is for the case in Japan. A normal incinerator that is able to process about 50 tons per day will cost you about $50 million. Whereas our technology with the same processing amount per day, it's 10 million. And the operation cost is, as you can see, quite different. The installation area is not that big as well.
Even you can set up in the town, in the city.
Yeah,
You don't need to go far away.
because the sound that you hear right now is actually the processing sound itself. Yeah. And when you compare to a landfill, this was taken, I think, when I went to Tanzania in 2019. There was some implementation happening. But for our technology is that, as you can see, once it's completely inside, there's no smell, there's very little smell. And then, of course, there's no decontamination of the soil or underground water. So there's the basic, so this is the demonstration machine, but there's basically two types, a 3 ton per hour or a 6 ton per hour. Now what is the difference is that a 3 ton is just one single processing chamber. A 6 ton is like what you see here, 2 processing chambers. Now because it processes in batch, so once, for example, tank number 1 is in process, then you prepare tank number 2. And when tank number 1 releases it, then you do you process tank number 2. So in that sense, you're able to continuously process waste. The processing time is about 1 hour, and you can, in Japan, currently it uses kerosene for the boiler, but you can use diesel as well. And then, of course, you naturally need electricity. The electricity usage, fuel and water, what you see here is just what you see in this demonstration plant itself. It does not take into account the after process. That will differ depending on how you want it to, if it's fertilizer or fuel. So yeah, that's the basic introduction to our technology. So if you have any questions?
How much it costs?
So for this entire unit here itself, it's approximately
Just now, but look at the pricing.
No, that is not pricing.
No.
That is the...
yeah. So approximately this entire unit here itself is about from building up until this entire thing is about 50 million, including
No, your equipment, building no. Equipment only. Your
equipment only.
only equipment, yes.
Oh, just here. これって大体いくらですかね。
Only
機械装
equipment.
置
Building no.
日本で大体このセットで
12億。Give me one moment. Let me change that to
青瀬が今160円です
this one. Which is about 7.6 million USD, which is about
21 million ringgit.
yeah,
建物の工事入って
12億。物だけが欲しい。
物だけだと
This one including the building.
10億くらい
No.
10億。
Yeah, yeah, down. 10
About 6.3 million dollars just for the
これ
equipment.
できた後に
25 million ringgit.
Yeah.
発電するところまで
So this includes 付帯設備も含めてっていうことですね。So it includes the two processing machines, the after process as well as the generator system as well.
20キロワット
Including boilers, condenser and everything.
Yeah.
The whole
Complete
set.
set.
Yeah, the complete set.
Everything container. All of it, yes.
さっきの10度